Alright, we've got two more exponent properties to learn. The first one is the division rule. So let's see what's happening here. In my rule, x cubed and y squared, and x squared in the denominator, y to the fifth in the denominator, suddenly only became 1x and 3y's. Let's see why this is working. Alright, so if I have x to the third, we're going to write this in our expanded form again. So that means I have 3 of them. If I have y squared, that means I have 2 of them. X squared, 2 of them, y to the fifth, 5 of them. Alright, so this is what I have. And if you notice, I'm repeating a lot in the numerator and the denominator. Remember, anything that repeats top and bottom, like say 2 over 2, that actually equals 1, so we don't need to write it. So this we don't need to write, this we don't need to write, this we don't need to write, this we don't need to write. But hey, look what I have left over. X on top, 3 y's in the denominator. So the simple rule is this: when you have the same base in the numerator and the denominator, so another way of saying that, in the top of the fraction and the bottom of the fraction, you get to take the smallest exponent and subtract it from the largest. Again, we're avoiding negative exponents here. So let's try that again. If I have a y and a y, then I get to cancel out the smaller one by subtracting it to the larger one. So I have x, 3 minus 2 is 1. There's my ninja 1 right there. I have y fifth minus 2, y to the third. Another thing I want to point out that I did is see where I took the subtraction in the numerator? I left the answer in the numerator. If I did the subtraction in the denominator, I need to write the answer in the denominator. Don't switch those top or bottom or anything like that. Make sure you leave them where you solved them. So let's try a couple practice problems and see how you're doing. First one right here, I've got 1x in the numerator, 3 y's, 2 x's in the denominator, and 1 y. So I get to cancel the smaller one to the larger one of my x's, and the smaller y to the larger one. So if that's having trouble seeing that, that was y cubed minus 1, that's y squared. And then over here I had x squared minus 1, which is just now x. And we're all done. In fact, I'm going to try to zoom in just a little bit more to make these a little easier. Let's try 200 there. There we go. That's much better. Alright, for example number 2, I have 12 over 16. And notice that those are just normal numbers, they're coefficients. We can divide those and reduce them like a normal, simplify those like a normal fraction. So they're both divisible by 4. So I'm going to write the simplified form of those, 3 over 4. Anytime you have a fraction already written for you, start there. It's just a good place to get that fraction bar going and top and bottom around. It'll just help you out. Alright, now let's see what else I have. I have an x to the fifth on top, to the 8 on the bottom. So I'm going to subtract the smaller one to the larger one. The answer goes on the bottom then, so x to the third. Anything else I didn't touch? That y to the 7th has no partner. All he needs to do is be exactly where he started. So on the top right there, y to the 7th. Alright, my next example. 4 over 2, I've got s to the 7th on top, s to the 5th on bottom. So first thing, 4 and 2, both divisible by 2. Let's just reduce that fraction like normal, simplify it. So I've got 2 over 1. And then I've got more s's in the top than the bottom, so I need to cancel those out. 7 minus 5 is 2. So this answer is fine, it's correct, but we usually don't need to say divide by 1 there. It's not making that any easier. So the real answer that I'd like to see on your paper is 2s to the 2nd, or 2s squared. Now this one looks very similar, and a lot of you would give me the same answer for both of these fractions, but notice this one says 1 over 2. So would you prefer $2 or half a dollar, 50 cents? That fraction really does change the value of that a lot. Now I'm looking at my s's. I've got 3 on top, 5 on bottom, so I need to cancel them from the top to the bottom. So I have 2 s's now in the denominator. So final answer, 1 over 2s squared. Now notice here, you do need that 1 on the top. It's a placeholder to show that this is in the denominator down here. Again, I didn't want to say that I had $2. I wanted to say that I had $1/2, so 50 cents. Alright, so let's go back and let's see what we have left here. We have our negative exponents. So I don't know if you've ever seen a negative exponent, but let me kind of explain to you what's happening. When you have 2 to the third, I'm telling you to multiply 3 times. 2, 3 times. If I have 2 squared, 2 of them. If I have 2, 1 of them. Hey, there's that 2 to the 0 again. Remember what we said that was equal to on that first page? We said that was equal to 1. Now here's why. What you've never noticed is, and because it never came up, you've got this times 1, this identity here, meaning it's not changing the answer. It's a little ninja 1 that's been sitting there the entire time. You're taking this 1 that's been out in front of this the entire time, and you're multiplying it by however many 2's that you have. Well, this one says, hey, I have no 2, so really all I've got is that ninja 1 there. Now, the way you've been looking at it is you've always been thinking of it up, like you've been thinking 2 times another 2 times another 2. But what if you start thinking of that going down from 2 to the third, 2 to the second, 2 to the first, 2 to the 0th? Notice now that you're really dividing by 2, and that's exactly what happens when you get to the negative exponents. You put that ninja 1, and it says divide by 2 one time. This one says divide by 2 twice, and this one says divide by 2 3 times. So any negative exponent is actually a variable, a base, that's on the wrong side of the fraction bar. So this one looks like there's no fraction, but really there always is. This one needed to move to the denominator. This ninja 1 was sitting on top the entire time. And this ninja 1, again, had one right there. It moved up, so I don't know if you can still see the fraction here, but there it is. We just don't need to write all that information. We move this x to the top. Once it moves back to the proper side, it no longer needs to be negative, and you're done. So let's see an example right here. I've got x to the negative 2, which means the x is on the wrong side. So we're going to move that to the denominator. Now you could really move it to either side of this y, but we like to alphabetize. So I'm going to put the x first. So now I have a x to the positive 2, y to the third. I need to show that they're in the denominator, so I'm going to put that ninja 1 on top. Alright, for this next example, I've got a lot going on here. The first thing I should handle are those negative exponents. So this y is in the wrong spot, it needs to move down. This x is in the wrong spot, it needs to move up. So I'm going to rewrite it. My x squared is fine, but it's now going to be joined by a x to the 5th. Order here does not matter. On the bottom, I've got that y, and now it's going to be joined by a y cubed. So all we did was move anything with a negative exponent to the other side of the fraction and make it positive. One last step, I shouldn't leave these multiple things around. This is actually the product rule from a while ago. So all we need to do is put these together. I've got 2 x's and 5 x's, so I have 7 x's. And I have 1 y and 3 y's, so I have 4 y's. And now you are all done and simplify. So if you see a fraction, go ahead and simplify it if you can. These are both even numbers, so they're divisible by 2. So my starting point here is going to be 5 over 6. And then I see I have x to the negative 4th in the denominator. Hey, it's not allowed to be there. So we are going to switch that to the top so that it is positive. So the first thing I'm going to write is the x squared that's already there. The next thing I'm going to write is my x to the 4th. Now it's positive because it's switched sides. Last thing you should do, don't write x's like that. Make sure that you combine what you can. So we've got 5 x to the 6. I had 2 of them and 4 of them, so I added them. And then right here, over 6. Alright, next thing. Got a negative exponent here, and that exponent belongs to just the thing in front of it, just the y. That 2 right there is negative, but it's not an exponent. It's okay just to be a negative 2. It's just a negative fraction. So leave that guy alone. He's fine where he is. Don't mess with him. But this y to the negative 7 needs to move to the denominator, so I'm going to move him down here, circle him. He's all done now. Alright, last one. It's actually one of the easier problems, but I find a lot of students struggle with this. There's not a lot going on. You have to make your own fraction. Everything's always over 1. So when I say that the n to the negative 38 is on the wrong side, you've got to move them to the denominator. And now we've got to show something's in the numerator. This one is still right here, so we've got to put that other ninja 1 that's been up top the entire time. So the simplest way of writing this is 1 over n to the 38th. You'll get used to that, no problem soon, and not have to show any middle steps. Alright, that's it for today.